they've not just flagging my videos so I can't monetize them, which is fine because I don't want to monetize them anyway, but they've been striking them down and saying you can't even have it on YouTube. Awful. So I gotta wait until that music ends. All right, so number 2. Speaking of Barack Obama, Barry and Ahmadinejad. Barry is short for Barack. Ahmadinejad is short for nothing. We're playing cards. Ahmadinejad dealt 22 cards to Barry and 22 cards to himself. He then realized he needed to only deal a quarter of the 52 card deck to each player. So he took some cards back and apologized for his error. How many cards did Ahmadinejad take back if he and Barry ended up with the correct number of cards? Well, I guess we need to figure out what the correct number of cards is first, right? How many cards should they have? How'd you get 13?
It's a quarter.
Quarter of 52, right? When we quarter something, we said of, right? Quarter times 52. Or you could be clever and say, well, isn't that the same thing as just 52 divided by 4? Of course it is. Now, maybe you don't know 52 divided by 4 off the top of your head. But isn't 52 divided by 4 the same thing as 52 divided by 2 twice? Right. Makes sense. 4 is 2 times 2. So what's 52 divided by 2 once? It can be 26, right? It's like 25, but one more, right? And then divide by 2 again. 26 divided by 2, 13. That's how I do quarters in my head all the time. I divide in half and then divide in half again. So 13 cards is what they should have. Right? That's what they should have. How many cards did he give him? 22. Okay. So how many cards does he got to give back? Whatever 22 minus 13 is. How would you do 22 minus 13 in your head? How would you do it? Give me one way. What are you going to take away first, Alex? Take away 2? Okay. How much more do we have to take away after that?
1.
Try again. Oh, you do 2, then 1, then 10?
Yeah.
Okay, we can do that.
10.
That's the same as subtracting 13 altogether, right? Subtract 2, take 2 away, then take 1 away, then take 10 away. That's taking 13 away. The reason we like this, Maddie, is that that's easy. That's 20. And then we could do 20 minus 1 minus 10 in our heads. What's 20 minus 1? 19. Take away 10. 9. What's another way to do it?
22 minus 10.
22 minus 10 first. Let me zoom out. And then subtract 3, right? What's 22 minus 10? 12. And then we have to do 12 minus 3. Now, maybe you don't like 12 minus 3 either, right? If you know the answer, it's 9. 12 minus 3 is 9. What if this was the original problem? How would you do 12 minus 3 in your head? 12 minus what first? What'd be easy? Isabel, what would you do if you had to do 12 minus 3? Don't know? You just do it. Take 3 away. Take away 2 first, and then 1. So if we take away 2 first, it's easy to do because it's 10, right? And then minus 1 more, we get 9. So Maddie wasn't here yesterday. This is something we've been doing pretty much all year, more or less. But if I have a problem like, I don't know, 24, and I want to take away 5, that might be intimidating to do in your head, and you're like, oh my god, I gave this die change, right? Something like that. It's the worst. I hate doing it too. And so what I do is I don't do 24 minus 5 in my head because I will screw that up. What I do is I do 24 minus 4 and then take away 1. Does that make sense? Right? I can do 24 minus 4 in my head. It's 20. Right? And then take away 1, I get 19. So it's breaking it up. This way we said, I don't know what 22 minus 13 is. So I took away 10 first and got 12, and then took away 3, which I know 12 minus 3 is 9. But if you didn't know it, you could do 12 minus 2 and then take away 1 more. Okay. So the answer is 9, right? Mr. Eads, need a volunteer. Come up to the front, where I was. All right, who can read and tell us how the story goes? Do you want to be Barry or Ahmadinejad?
I want to be Barry. It's easier to pronounce.
Makes sense. You have the same ears as him. All right. All right. Here we go.
What are we doing?
Here's my deck. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I got to count these because I taught summer school over. I did summer camp over this summer. Got little kids playing with these, playing garbage. There might not be all 52. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. All right, so these guys come out. So, I'm Ahmadinejad, he's Barry, so I'm dealing, right?
What in the world?
Look, sometimes the clothespins have babies. It's okay.
I think they gave birth a little too early.
Yeah, maybe. It's okay. Right. That's why we have blood drives. What? Preemie pins, there you go, right? Clothespins for little guys. Alright, so, I have 52 cards. I'm Ahmadinejad. What does Ahmadinejad do? Somebody read me the story. What happens? 22 cards, so 22 to each, right?
Yeah.
Alright. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, pick up your cards.
Would have been just easy if you counted 44.
It would have been easier to deal this. How? How could I have dealt this a lot faster?
You go 1, 2, 3. So 1.
How could I have done it faster?
Done about 10.
Anyway. Well, I want to deal 22 and 22. How many cards did I deal total?
44.
44. So I could have figured out how many cards are left over. What's 52 minus 44? Do that in your heads. What's 52 minus 44? I'm going to do 52 minus 40 first. What's that? What's 52 minus 40? 12, right? So I want to subtract 4 more to do 52 minus 44. What's 12 minus 4? Take away 2, take away 2 again.
8.
Ocho, right? So I can figure out there are 8 cards left over. Just taking all these and just going back and forth as fast as possible. No counting required, right? So I got 22, you got 22.
There's so many cards.
Okay. I've got a couple of aces. Right. Looking good, looking good. Oh, I got 3 aces. You're going down, man. If we played war right now, I would win.
I think I got all the cards.
Which is, I think, a metaphor for, like, war in the Middle East. All right, so anyway. So I got 22 and 22. Now what are we doing?
You have to take it back, bro.
How many do I take back, right? I want to get down to 13, right?
Take back 9 cards.
So if I take back, I've got 22. How many cards do I need to take back to get to 13? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And according to us, right, if I take back 9, now I've got the right amount of cards, right? I've got 13. Does he have 13? He doesn't. He still has 22. So how many cards do I actually have to take away? 18. Where are your 9?
Right here, it's my
So we take away 9 from both, right? So 18 cards back total. Now, question. If I just took back 9 from me and 9 from him, and we originally had 22 each, if I add the cards left over in the deck, how many cards are in the deck now? How would you solve that problem?
Wait, how many did we have before?
Well, we had 22 each, right? I took back 9 from both.
18.
How many cards are in the deck now? There are 52 cards in the deck.
Wait, we have 13. Right?
Mm-hmm.
So 52 minus 26.
Mm-hmm. Which is?
I don't know. But I have paper and pencil.
Yeah, I know. No calculator can't do it. Who can do 52 minus 26 in their head? What's 52 minus 20? Well, there's one way of doing it. Don't we each have a quarter of the deck?
13. No.
If I've got a quarter and he's got a quarter. If I've got a quarter and he's got a quarter, how much of the deck do we have together? 2 quarters makes what?
Yeah,
half, 26, right? So how many must be left over?
26.
26. We both have half, right? Like, together we have half, so what's left over must be the other half. 26, 26. Put that away. Thank you for your volunteer. Oh, wait, actually, let's play one round of war. Real quick. Here we go. Ready? You know how to play?
Yes.
All right, good. Flip, go. All right, that's me. Ooh, it's you. Go. Ooh, war. Here we go. Three and then flip. Can you guys see this? All right, get on the screen, you dingus. Okay, it's live. Ready? Go. Master. All right. Once again, a metaphor for war in the Middle East. Don't do it. It's my home turf. All right. See you later, Barry. Cold-blooded. And take your stuff and go home. If only it was that easy. Thank you. I'll be here all week. Get this thing out. Yeah. See if I've got the OG copy. That stands for Optimal Gorilla. Here we are. I'm getting all organized. I got 20 million bins and still not enough to get it all taken care of. Just got through all the late work. This is the late work as of today. Never ends. All right, so here we go. Good thing I don't grade your life skills. Everybody would be failing. So, yesterday we were talking about the circumcenter. It looks like a bunch of mumbo jumbo now, right? Here's the idea. These are perpendicular bisectors because they hit at 90 and they bisect the side, right? So if they bisect the sides are going to be equal. Then we did P5 to figure out what this was. It was 16, and so on and so forth. Over here we did a bunch of stuff. I'm going to get rid of that and get a fresh copy. I think it's easier to see in real time. Let's look at part A, B, and C. So it says the perpendicular bisectors of triangle ABC meet at point D. What does it mean to be perpendicular? Hits at 90, right? So here are our 90 degrees. What does it mean to be a bisector? Help yourself to this if you want. What does it mean to be a bisector? Bisect. Can be, right? We can bisect angles, right? But a regular bisector doesn't bisect an angle. What does it bisect? Segment, right? A line. So if this right here is a perpendicular bisector, and it's perpendicular, and they said it was a bisector, that means it bisects this side into two equal pieces, right? You with me on that? Well, DF is also a perpendicular bisector. So if it's perpendicular, it must also bisect. That means these are equal pieces. ED, no joke. Perpendicular bisects the side, right? So those are equal. Cool. Now, hopefully you remember, D is the center, but what center is it? Is it the in-center, the circumcenter, the medicenter, the centroid, or the in-center? Well, let's go through them. Oh, wait. You guys don't do medicenter. The centroid's the one you always want to say, right? That's the center of mass, the balance point, right? On the triangle. How do we find the centroid? What kind of lines do we draw? What are those called? I like to call this the medicenter because it helps me remember what the segments are. Medians, right? And medians are vertex to midpoint. Now this line right here, is that vertex to a midpoint on the opposite side? Oh, it looks like it, right? What about this one right here? Oh, it stops right there. So it's not vertex to midpoint, is it? Right? So we must not have the centroid. That's not what we're dealing with. Okay. What about the in-center? What's the in-center? What do you remember about the in-center? Not much, huh? It's the intersection of the angle bisectors. So it's the lines that cut the angles in half. These lines don't say they cut the angles in half, so we don't have that. Also, the in-center is a circle that fits perfectly inside the triangle. Is that going to make a circle that fits perfectly inside the triangle? Nope. Not going to be the center of a perfect circle, right? That's the circle. Center would be like here or something, right? What? Which one? Orthocenter. So let's check that one out. Now this one's pretty close, but actually isn't right, but it will get us to the right one. It's not the orthocenter. Now you might think that because like, oh look, perpendiculars, right? Orthogonals, right? But they're not just orthogonals. They're also perpendicular bisectors, right? Right, so they do both. It's not just 90. If we didn't have those marks there, then yeah, it'd be the orthocenter, right? But it's more than that. It's the circumcenter. That's the center that's made by the perpendicular bisectors. Now, the incenter is a circle inside the triangle, right? Circumcenter. What kind of circle is that? Outside, right? Like circumnavigate. Like Marco Polo circumnavigates the globe, right? Goes all the way around. Beautiful circle. And it hits all our vertices, doesn't it? That means the distance between D and C is a radius, right? Of the circle. Right? Now this is a terrible circle, but in theory, when you draw a circle, right, all the radii should be the same. No matter where you go from the center to the outside of the circle, it'll be the same distance. So D to C is a radii. What's D to B then? What do we know about D to B? D to C is a radii of the circle. What do we know about D to B? It's going to be the same, right? They're radii, right? They're going to be the same. So all of these lengths are the same. This means that D is the same distance from every point on our, or every vertice on our triangle, right? The pointy parts. So the distance from each vertex to D is the same. So if we were to draw a triangle, any old triangle, and we were to measure the same distance in from each of these guys, right there would be the circumcenter, the center of the circle that perfectly goes around it, right? If I draw a right triangle, looks like we're here, right? Same distance from all the parts. So we get a circle like this. Center's right here. That's the circumcenter. And if we get an obtuse triangle, looks like same distance is going to be here, right? I got to have a circle. It's going to be a huge circle to make it up, pull it off. So the center is going to be out here somewhere, right? Does that check out? Circle's got to touch every vertex, right? In order to do that, I got to make a pretty wide circle. So my center is going to be out here. So acute, it's inside. Right triangle, it's right on the midpoint of the hypotenuse. And then for an obtuse triangle, since it's so big, it actually pushes the center all the way outside. So this one's inside. What kind of triangle must ABC be? Tucker, this is all you. For an acute triangle, the circumcenter is on the inside, right? For a right triangle, the center's on the hypotenuse, the midpoint. For an obtuse triangle, it's on the outside, right? Because in order to make those three into a circle, it's got to be a big circle. So this guy, point D is the circumcenter. What kind of triangle must ABC be? Acute, right, or obtuse?
No.
Center's on the inside, right? Must be acute. All those angles must be acute. Cool, cool, cool. All right, so let's get to the actual problem. Find DB. Well, if you're like Mr. McCartney, you would say, well, it's right there. And call it a day. We want to find the length of DB, what it actually measures. How do you know it's 14, Eads? Yep. This guy's 14, right? All of them are 14, so it's 14 because AD equals DB. I don't need the reasoning, I just want you to see why, right? All these are the same length because they're radii of this big circle. So if that's 14, that must be 14 too. How long would DC be? 14 as well, right? They're all radii of the circle. If I were to draw a line from D to here, how long would that be? It'd be 14, right? It's the radius of the circle, right? The reason these are special is because they happen to be also points on our triangle, right? Cool, cool, cool. Nice job. AE, that's this green part right here. Well, the whole thing's 22, and this is a perpendicular bisector, so it cuts it in half, right? What's half 22? 11. All right, we're going to find ED. Tells you use P-tag. Don't worry about simplified radical form. We're going to talk about that in a second. So ED is this little bit right here. Didn't we just find out this is 12? And that this must be 11? Right? This bit right here. How can we figure out this part? Alex. Say it again. Why times? He said 14 squared and 11 squared. Add them, right? We're doing P-tag. Right? Now, is 14 a leg or is it a hypotenuse? It's a hypotenuse, right? It's across from the 90 degrees. It's the biggest side. So what we need is this. 11 squared plus the side we don't know squared. I'm going to call it ED. And that should equal 14 squared, right? Cool. Now be careful. What Alex said is he was going to add 11 squared and 14 squared. That's true if 14 was a leg. Does everybody see that that's the hypotenuse? It's across from the 90. Isabella, do you see what I'm talking about here with the 90? Okay, cool. So it's the hypotenuse, so it goes here. 11 squared. All right.
22.
That's 11 times 2, Eads. What does it mean to square a number, Mr. Eads?
1 times 11.
Times it by itself. Now, I don't know 11 times 11 off the top of my head. But I do know something. I know 11 times 10. What's 11 times 10? 110, right? 11 with a 0 on the end, right? So this is 10 groups of 11, right? That's what that means, 10 groups of 11. If I've got 11 groups of 11, that's one extra group of 11, right? So to get from 10 groups to 11 groups of 11, what do I have to do? I'll say it again. If I've got 10 groups of 11, and I want to get to 11 groups of 11, what do I got to do?
Add 1.
Add 1?
Hey, you're at 11.
Also, the answer is this. I didn't add 1. What did I add?
21.
I added 11. I added another 11, right? See how that's 10 11s and that's 11 11s? So if I've got 10 11s, if I add one more, I've got 11 11s, right? So I got to add 11 more. If I want to know 3 times 4, right? I bet you know it. And I don't. What if I know 3 times 3? 9, right? What does this mean? 3 groups of 3, right? I want 4 groups of 3. How many more groups of 3 do I have to add? 1 more group of 3, right? What's 9 plus 3? 12. Right, it's 1 more group of 3. So you just add 3 on. I got 10 groups of 11, that's easy. I can use that to find 11 groups of 11, much harder question, right? I can just do that and add 11 to it. It's 11 squared, 121. ED squared, well, I don't know what that is. That's what I'm looking for. 14 squared. That's a tough one. How would you solve it? 14 squared. That means 14 times 14, right? I don't know what that is. What do you know? How would you solve it? A couple different ways. 4 sevens? I mean 14 sevens? 4 sevens. A little too advanced. You could in theory, but we're not going to mess with that. What would you do?
7 times 7 times 7 times 7.
Well, if you did 7 times 7 times 7 times 7, that's 49 times 49, right? Do you see what I'm saying? Right? You'd want like 7 plus 7 times 7 plus 7, something like that. You could do something like that. Yeah?
Do you do 2 times 7 times 2 times 7?
I'm going to make this one a little bit bigger. Right? It's all multiplication. Is this the same as that? Is 2 times 7 times 2 times 7 the same thing as 14 times 14?
Yeah.
It is, isn't it? Now, it's the same, but why does that make it easier? Can't you do multiplication any order you want? What's 7 times 7?
14, 49.
What's 2 times 2?
1.
Now, you might think, oh, great. Well, I don't know that. Yeah, you do. What's 4 times 50? Well, if I got 50 groups of 4, hold on. You gave me one too many, right? I only wanted 49 groups of 4. I gotta give you 4 back, right? Like Ahmadinejad.
175.
Well, you got $200, and I say, can I have $4 change, and you give me 175, right? Right? One less group of 4. What'll that be? 196. Nice job, kid. Maddie with the SD. Two points. Solid stuff. I'll put that on the spreadsheet. Self-development, you need 20 per semester. You're on your way, though. Whenever you come in and get help, you get self-development. If Ms. Bechtel, if they come to you for a test retake or whatever, remind me and let me know. Usually we talk anyway, but like if they do without me knowing, let me know, and I'll give them self-development points for that. Okay. Guys, you can be responsible for that too, because this is semester 2 for you. It's semester 1 for the new kid, right? Make sure you know. All right. So that's one way of doing it. 196. Yeah. Of course. You don't have to ask. Sign out if you want. All right. So that's 196. Another way to do it might be 14 times 10, 140. 14 times 4, figure that out, add them together, right? I like Maddie's way. That was good. All right, now how do we solve a problem like Maria? We got to get ED on its own. What would you do first? I'd go for the easy stuff first, right? Squares, right? Let's move that over. How am I going to move it over, Alex? Yep. And so we get ED squared on this side. 196 minus 121. Well, what's 196 minus 100? What's 196 minus 100? 96. What's 96 minus 20? 76. What's 76 minus 1? The amount of money Eads almost gave me when I asked for $4 back. All right. Now, how do we get ED instead of ED squared? How do we undo squares? It's not divide by 2, right? It's how we undo multiply by 2.
Square root.
We got a root, yep. So we get root 75. Gross. Let's estimate that. You don't need a calculator. You don't need a calculator for this. Root 75 is going to be between 2 other roots. Now, I don't know what root 75 is. But what number sort of close to 75 do you know the root of?
50.
You know root 50? What's root 50?
What's
Use the calculator you got and check it. You don't know it.
No, it's a road. That's what I said, the interstate.
He was funnier. All right. What other number do we know that we know the square root of?
70.
You don't know 70. 100.
You don't know, right? That's obviously.
That's 10, right?
No, 5.
What other number next to 75 do we know the root of? Square root. What? 25? Eh, too far away from 75. We can think of a better one than that. We can think of a better one than this too, but I won't hold you to it yet.
Start with your doubles.
60.
10 times 10, 9 times 9, 8 times 6, 7 times 7, 12 times
80.
80.
50.
Square root, it's a number times itself, right? What number times itself gives me 80?
81.
Ooh. Root 81 is going to be bigger than root 75, right? And that's 9. So it's going to be less than 9. What's another root we know?
49.
7 times 7, 49. Can we get closer to 75?
Yeah.
8 times 8, what's that?
64.
Okay. Root 64 is 8. So what must root 75 be? It's between what and what?
8.6.
Between 8 and 9, right? Somewhere around there. It's like 8.6. That was my estimation, but I'm not a calculator. Anyway, when they say simplest radical form, here's what they mean by this. If I were to give you root 4, what's the root of 4? 2, right? It's asking what number times itself gives me 4? 2, right? What's the root of 9? 3, right? We found out root of 64 earlier, it's 8, right? Root of 81 is 9, etc., etc. Now, the reason that becomes 2, can I write 4 as 2 squared? Don't roots and squares cancel? That's why I get 2. Can I write 9 as 3 squared? Don't roots and squares cancel? I get 9. What does it mean to square a number?
Double it.
Times it by itself. So what we're going to do is we're going to break down 75. There's no number I can get that's times itself to give me 75, right? But there might be some numbers inside 75 that are doubles. So here's what I mean by that. How can I break up 75? What's 75 divisible by? Ooh, 25. 25 times what gets me 75? 3. Man knows his money. Unlike somebody.
What?
Right? So I could rewrite that as this, right? Couldn't I rewrite that as 25 times 3? Now that's not helpful because I didn't get like 2 times 2 or 3 times 3, right? But can I break down 25? 5 and 5. Can I break down 5s or 3s anymore? No, 5 and 1, 3, they're prime, right? So another way to write root 75 is 5 times 5 times 3, right? 25 times 3 is 75, right? But what do you notice? What's 5 times 5? 5 squared, or 25, right? Don't squares and roots cancel? So if squares and roots cancel, the 5 gets out. Does the 3 get out? No, he stays in. So another way to write root 75 is root 3 times 5. Because you can pull out one of the 5s. We're going to work with this more the rest of this week, but that's the general idea. You break it down, you see if you get any doubles, and if you do, they come out. Right. Let's do one more practice. So for that one, the answer should be 5 root 3 in simplest form. 5 times root 3. Okay. 5 root 3. Let's break down another root. I was thinking more like 144. Now maybe you know it off the top of your head, maybe you don't. Let's pretend you don't. What's 144 divisible by? Definitely 2, right? It's even. What's 100 divided by 2?
50.
What's 40 divided by 2?
20.
What's 4 divided by 2?
22.
So in total, that makes sense. 2 times 72 gets me 144, right? 2 times 70 gets me 140, right? Can I break down 2 anymore?
No.
Nope, it's done. What about 72? What's it divisible by? 2. I'll accept that. So what's half of 72? What's half of 70?
40.
What's half of 60?
30.
30. What's half of 80?
34. 40.
40, right? So 72 is between, or 70 is between 60 and 80, right? Answer's 36. We're running out of time. I'll leave it at that. 2 times 30 is 60. 2 times 6 is 12. 60 plus 12 is 72. How'd I break 36 down? 6 and 6. There we go. Bigger numbers makes easier job. Whoops, don't circle those. 3 and 2. So I can rewrite this as 2 times 2 times 2 times 3 times 3 times 2. What is 2 times 2? 2 squared, right? Squares and roots cancel, so 1, 2 gets out. 2 times 2, that's 2 squared. 1, 2 gets out. 3 times 3, that's 3 squared, so 1, 3 gets out. I've got nobody left in. So I've got 2 times 2, which is 4, times 3, which is, well, 12. We'll work more on this later. Oh, man.
Dude, are you joking?
I need a pen can just for that. Get that back on the slow-mo.
You put that on TikTok, you go viral.
That's right. That's what we're here for. When I became a math teacher, I was like, there will be a thing called TikTok. I'll become famous because of being a math teacher on TikTok. I start my journey now. We'll be playing with more numbers tomorrow. Kobe.
Jay plays war again.
You lost last time. Don't you ever learn?
Can I go put my stuff away?
Get out of here. Go enjoy lunch. You're welcome. You call it a jail too? So do I. I talk about Shawshank Redemption, right? You gotta stab your partner in the back and you sneak out in his body bag, which is why we wrap it and we put it outside the jail. Right, in parentheses. And I thought I was radical. Here you are.